So today I'm going to talk about more about Aurora databases. It's specific to AWS. So before getting to that, I just would like to know how many of you are running your workloads on AWS? Okay. So are you using Aurora or RDS databases for your database structure? Okay, great. So today's talk is more about the Aurora specific, but definitely yes, RDS supports, we can replicate to Aurora. So this strategy is more into DR perspective, right? So because if you are in a fintech industry or anything to financial or any industry, DR is very important. But when it comes to fintech perspective, it is actually compliance. You must have to have it, right? So Hyderabad region is very recently opened. So why I choose this topic? Because from past couple of months, we are doing a lot of DR for a couple of our fintech customers because they wanted to set up a DR due to regulation and compliance perspective. They want to keep the data in India only, right? So previously they didn't have any proper DR setup. Now we have Hyderabad region, so we are actually setting up the DR from Mumbai to Hyderabad. So during these activities, we noticed like a lot of problems while configuring this. Everything works perfectly in the paper, but when you're going to deploy something, it will not work, right? There are so many issues that we face while deploying, specifically the global cluster in Aurora. Many features are not documented. And when you go with just reading the document or doing some small set of workload assessment, right? Generally we do it, right? We just launch our test cluster, we run this failover test, it'll work fine. Then we'll definitely go for production. But that time you will face some issues, right? That's what happened to us. So this is our learning. That's why I wanted to have a discussion, like just sharing my knowledge with everyone. That's the intention of picking this topic. Just a small introduction. So, myself, Bhuvanesh, I'm the co-founder and CTO of a company called Shellkode. I'm actually in the industry for more than a decade, and I played multiple roles in my past. So, I started my career as network engineer. Then I jumped to cloud architect role. Parallelly, I was doing DBA, and then I became a full-time DBA. Like almost like 8 years, I was managing multiple databases. Couple of customers I handled like Dream11, Flipkart, and then Tata Sky. These customers I handled it in my past, and Hangama as well. So that's the experience that I have with setting up the large scale database infrastructure with scalability, availability, all those perspective. I mean, typical DBS stuff, right? And then I moved to data engineer role, like playing data pipelines, setting up like real-time pipelines, Kafka, all those things. Like multiple roles I played it. So this is a little bit of introduction about my company. So Shellcode is more into cloud professional services. We provide support in terms of migrating to cloud. It can be AWS or GCP or Azure. And then if you want to modernize your infrastructure with DevOps, all those Kubernetes things that we can do. From data perspective, data engineering, analytics, data ops, and then AML. Right now we are the Gen AI industry as well. So we are one of the top second partner in India to work with closely AWS to enable the Gen AI for the customers. And we are top 5 partners in India to work with any kind of AWS workloads with the AWS ecosystem. So that's our achievement. So let's start with the Aurora. Like I know a couple of you already using AWS, right? Just to like make everyone aware about how Aurora is different from traditional other databases, right? So in TiDB docs, Bono clearly mentioned that Aurora is they saying it's a distributed databases, but not actually, right? That's actually true. So you can actually see that, right? Aurora actually decoupled your compute and storage layers, and the storage layer and compute they both can individually can scale. They are distributing a storage and compute. That's about it, not the data actually. So he properly pointed it out. So you can see that, right? So in AWS, there's a concept called regions. You all aware about it, right? And then availability zone concept. So whenever you're provisioning a Aurora cluster, it will create a clustered volume across multiple availability zone, minimum of 3. In Mumbai, you have 3, right? Similarly, in US, you'll have more than 6 availability zones. So minimum of 3 availability zones will be picked up when you are going to provision Aurora cluster. And each availability zone, you will have 2 different copies of your data. So we can see this, right? These 2 color codes. It's your data, right? So at least 2 copies will be maintained in each availability zone. So overall, 6 different copies will be there across availability zones. This is how they design the storage. And then this storage can be expandable in terms of 10 GB chunks. It will start with 10 GB. Whenever it is reaching a threshold limit, the other 10 GB will be added. That's how they are scaling their storage layer. And on top of it, you can actually scale your read workloads by provisioning multiple nodes. So Traditionally, how replication works, either we use binlog or MySQL means we will use swarlog files, right? But in Aurora's case, they are not using any traditional method of replications. They follow their own disk level replication methods because you already see the data is already copied to multiple regions, right? Then no need for creating one more nodes in a different region as a read replica because the data is already there in every place. You just simply provision one compute node on any one of the availability region and you can start reading the data from each zones wherever the node is provisioned. So that's how the replication actually works. And then like when you're comparing a throughput, right? So you know about IOPS, right? Volume IOPS. Whenever you're provisioning a volume size, your IOPS is depends on that volume size. But in Aurora's case, there is no limit on that. In my past experience, I could see the IOPS went to more than 30 lakhs while restoring one huge chunk of database. So it can scale how much the limit you want. But at the same time, you are charged for IOPS plus storage. So be careful about the IOPS part, right? Recently, they introduced a new concept of standard IOPS. So whether you want to scale your IOPS as much you want, or you want to limit your IOPS. Two options are there. You can pick whatever you want, so you can save some costs on your staging or non-production environment. Now coming to the global databases, right? So why this feature brought by AWS? Because it's a more simplified way of setting up your data structure. So you can see that, right? So you can see the primary database sitting on Mumbai, and you can have multiple copies in across multiple regions. And AWS guaranteed that at any point of time, the latency always less than 1 second. It is not written in SLA, but they are guaranteeing that it can be less than 1 minute only. So it's all powered by AWS backbone network, and they have like a lot of encryption between the connections, so that it will not happen. It will not deal with any jitters in the network. So and then you have one more option like global write forwarding, which means that you can actually send your write operations to any one of the clusters, and it will understand who is the primary cluster, and it will automatically route your write request to that primary cluster. So basically, you don't need to deal with that read, write, split operations. So it will automatically understand who is the master node. It will forward to that. And then guaranteed RPO, which is one another interesting feature. If you say like I want to my RPO will be 20 seconds or 30 seconds, generally it will be 0. But AWS provides a minimum of 20 seconds as a manager RPO. What does it mean? So whenever like your data lag is going beyond that threshold limit, then it will pause all the activities on your primary cluster until your one of the read replica will get reached, will solve that replication lag. So this is the architecture of global cluster, how it looks like. So on the region 1, let's say this is a primary cluster. On the region 2, you have a secondary cluster, right? So on the region, you have like multiple nodes along with the primary and secondary nodes, and you have the common storage. So they are using a specialized replication mechanism to replicate the data from one region to another region. So here you can see that, right, there's outbound replication and inbound replication. So the outbound replication is responsible for collecting the data from your source database system, and it is completely physical replication plus log based. You want the all log files, right? All log or bin log files. That will make sure that your data are going in the right order. So they are actually following that and enforcing that kind of architecture here. And then like it can support up to 5 different regions, right, so far. This is one of the screenshot I taken from AWS website. So generally, there is a small benchmark with that the traditional logical replication to replicate the data into multiple regions. The other one is like global clusters. You can see that, right? So whenever your number of QPS go increases, your replication lag automatically increase. But in global clusters, it's always consistent. So that's the benefit of using this global cluster instead of doing some logical replication. So in the global cluster, you have two different of failover methods. One is the switchover, which is like a planned activities you can do, like whenever you want to do some patch updates or some maintenance activity, right? You can gracefully switch out to your another region. This will guarantee that there will be no data loss. It is properly managed, but the downside of this will take minimum of 7 minutes. We benchmarked with multiple customers with various size of databases, and minimum it took 7 to 9 minutes. That's the benchmark. On the other hand, the failover is actually doing that. You will have some data loss, but it will be super quick. So within 1 minute, we are able to switch over to the another region. But on the other side, right? So like there's a new feature introduced very recently, I think 2-3 weeks before. Whenever the failover happens, for example, your primary is Mumbai region and secondary is, let's say, Hyderabad region. The moment when you fail out to the Hyderabad region, then your Mumbai region cluster will not able to accessible at all. It will be out of your clusters. And you have to take care of rebuilding your secondary cluster back. It's a manual effort. But 3 weeks before, there's a new feature introduced from AWS side that it will automatically rebuild the secondary replica. Even if you do manually click the failure button, the automatic rebuilding replica will kick in. So this process depends on your data size. If you have huge data size, then rebuilding the replica will take more time. But it will completely out of the box automated. We don't want to do anything. Just to click on the failover and let's wait for until the secondary cluster needs to be available. There is another feature with this global cluster. There's something called headless clusters. It's a kind of low-cost DR solution. So here, how the architecture will looks like. On the primary region, you can have reader nodes, writer nodes, or whatever, right? On the secondary region, you don't need to have any nodes because your storage only will be replicated, but there will be any nodes. So you'll be charged for only the storage, how much it is utilized it. During the DR time, you can actually add one more node into that and you can bring up. But there will be some, your RTO will be lagging in this architecture, but there is no data loss. It's like a low cost solution. And I was talking about the manager RPO, right? So it will make sure that whenever there is a, it will actually keep checking all of your secondary replicas. In this example, you can see, right, there are two different regions configured as the secondary region. And the minimum RPO that what AWS is providing is 20 seconds. And the maximum will be 68 years. That's the parameter value. We can keep it here. So but it will automatically checking like what is the latency or lag between primary and secondary. So in this case, you can see both the regions are having 25 and 35. And if you set it at 20 seconds as the minimum RPO, then it is a RPO breach. Then what this primary cluster will do, it will stop accepting the new writes from your application, or it will not allow anybody to commit any transactions until one of the replica catches the replication lag. Then it will start enabling it. It's a kind of weird behavior, but this is how they're ensuring that the RPO is met. And finally, the real world experience. This is what I wanted to share our learning, what we had. The first one, the dark side of global RPO parameter. This is the parameter will enforce your RPO is always met, right? So this parameter will actually behave in a different way when you do, like, for example, you have a primary cluster and secondary cluster, right? Let's say I have in the global cluster, I have only the primary cluster. I don't have any secondary cluster at all. But even though this parameter will enforce the primary cluster to keep checking this, what is the RPO, then definitely your transaction will get blocked. That's some weird behavior. Second thing, I have this global cluster and I set the parameter value. I have like primary and secondary. And then due to some reasons, we are removing both the primary and secondary out of the global cluster. Now both the clusters are individual clusters. There is no concept of global cluster here. But still, if the parameter group associated with your primary or secondary, still it will enforce the RPO parameter and it will stop blocking your transactions. And the another part, let's say I don't have any global cluster at all. I have a normal Aurora cluster, but unfortunately, I just added the parameter of like global RPO into that parameter group. But that parameter group should have work only in the global mode. But even though if you wrongly set it right, it will affect your region cluster also. How it affects, let's say I do a failover. I have AZ1, AZ2, let's say reader and writer, right? Even though within the same region, if you do failover, the parameter will still enforce and start blocking your transactions. So that's how I was talking about. You can see that, right? The moment when the failure happened, for next 2 to 5 minutes, you will not able to make any write transactions because the parameter will enforce your clusters to keep checking the secondary cluster available or not. And that's why there will be that's like a wait event of Aurora Global DB RPO total. So make sure that this parameter is properly handled. If you don't have global cluster, then don't touch the parameter, leave it default value. Or else whenever you are removing the cluster out of your global, please reset the value. Otherwise you will end up with these kind of problems. And the second learning is tailor certificate. So in this case, right, we provision the secondary cluster in the Hyderabad region. You can see that, right? We use the certificate of RDS CA 2019. I know this is going to be expired in next 1 year, but still it's valid. We created this CLI command to provision it, and the cluster got provisioned without any error messages or warning. But when you go and check the console, the certificate name looks like this. It's a completely different name. But on the primary region, we are using this RDS CA 2019, but the new cluster is having this one. Then if you're using a tailor certificate in your client application, there's a conflict, right? The certification will not match. Then definitely after the DR drill or after the failover, you will have a problems with your tailor certificate. So how do you make sure that it does not happen? So if you run this command, right, like RDS discuss certificate on each region, the first one is for Mumbai region. You can see 4 different certificates are available. But on the Hyderabad region, only one is available. So make sure that whenever you're doing a DR testing or creating something on the different regions, make sure that what are tailor certificates are available. And another interesting factor here is all other regions support, you can choose what kind of certificate you want. You can edit it. When you're doing the modify button, you can change the certificate whatever you want. But that modification button not at all available in the Hyderabad region because there's only one available and you will not able to modify after that. So how do you solve this problem? Let's say I have a primary cluster with this certificate, but secondary is having a different certificate. So how do I solve this problem? So there's something called global bundle certificate in AWS. You can download a global certificate which is applicable for any regions. One certificate can talk to all region clusters without any problems. So that if you use that certificate and it'll work out of the box, so you don't need to worry about that. And we tested that even though your primary and secondary are having different certificate, but using this global bundle, you are able to access both of them. So I have like two questions here. So people who are already in the AWS side, they might know the answers for this. So I have small goodies like whoever answering, I will give it to you. So the first question. So we talked about this global cluster, right? You have like primary in one region, secondary in another region. So what do you think about KMS? Do we need to create one multi-region KMS key and keep the same key for both, or can we have different keys? So maybe I'll go back to the architecture of this global cluster. So any idea after saying this architecture? Exactly. So data transfer happening through the network, not on storage level. So powered by AWS network connections. The replication happens through the network. So this is a separate storage. That is separate storage. You can encrypt here default or CMK. There also default or CMK you can use it. The replication between them are happening through network, some external replication. That's how it works. So you can have like, any KMS key you can select on any region. It will work. Can be same key with a multi-region or different keys for both. It will work. So second question, it's similar to it's a kind of networking question. Let's say I have primary region and secondary region. So mostly SREs might know about this concept. There's something called DNS resolution, right? So RDS will always give you endpoints, right? And the endpoints can be resolved only if you enable the DNS resolution on your VPC level or subnet level, right? So if you're thinking about a VPC pairing, let's say my primary region and secondary region is paired using network pairing connections, but still you're not able to resolve the private endpoints of RDS. Then what might be the reason for this? So you have pairing connection. So let's say Mumbai and Hyderabad, your regions, you have two different VPCs, both are paired and all the route tables are added. Connectivity is absolutely fine. But when I try to ping or telnet that RDS endpoint, it is not able to resolve that endpoint. It's not able to resolve the DNS names actually. But it's verified that both the VPC and then subnets are having the DNS hostname resolution option enabled. Again, it's another learning for us that we learned it. So, endpoint needs to be resolved, some IP, right? That IP is not able to resolve. Okay, the answer is still the DNS option only, but where do you want to enable? Any idea? That's a clue. It's okay, I'll just tell the answer. If you have a pairing connections, right? So if you check the properties of pairing options in the pairing properties, There also there's an option called enable VPC DNS host resolution. Even though if you paired that both the network, until you enable this option, the private DNS host names, either EC2 private or RDS private endpoints will not able to resolve. That option you can take it off. Okay, I'll move to the next one. So we're talking about, right? So keys. So if you have like both the regions, so I didn't update the name, but region 1, region 2, you can have like multiple keys. Region 1 can be configured with the default KMS key, and region 2 can be configured with CMK keys, or both are default, or one common key you can create and share across multiple regions. That also will work here. So that's how it works. And second thing about the pairing connection. Third thing will be security groups. So generally in AWS security group, right? Either we whitelist IP address or any pairing connections, or we can whitelist sometimes security group ID, right? But when you are in the pairing connection mode, you will not able to whitelist the security group IDs. It is possible if both the primary and both the networks are in the same region, or if a different region, that is not possible. Even though like let's say you have account 1 and account 2 different accounts, but the VPs are configured in the same region, then it is possible to use the security group IDs to whitelist the rules. But if they are in different regions, then it is not possible to whitelist it. Which means like either you can whitelist individual IP address or IP range of subnet or VPC. So here there's a small glitch because you are allowing entire VPC range or subnet range. Until your compliance team said go ahead, you can pick the option whatever you want. But definitely you cannot whitelist a security group ID of your other region, maybe EKS cluster or whatever. That's not possible. And one more option that I didn't add in the slide. So how many of you like using AWS SDKs in your applications? Developers, right? So if you're using an older version of SDK, the Hyderabad region or any upcoming regions, right, they will not have that option. So this also we encountered one error. So we're trying to access the DynamoDB tables using that our SDK, but it's throwing an error like Hyderabad is not able to found. Then we figured out the SDK that we are using is older version. That's not having the updated region list in that. So make sure that it is having the right software. And one final thing, again, it's not documented feature in AWS side. If you're enabling the global cluster feature, right? So in our use case, we were using the PostgreSQL version 11.17, but that version is not supported on the Hyderabad region. So 11.16 is supported, 11.18 is supported, but that 11.17 is not supported. Only that one version is not supported in the middle, but it is not documented. So again, you have to do experiments to get to know all these items. So that's all for this session.